everyone. I am Priya Mishra, Assistant Professor in the MCA Department from ABES Engineering College. Today I am going to discuss the concept of NFA and a DFA in front of you. So from the beginning of my lecture, I will discuss what is the automata. Further, I discuss what are the elements of the automata, then the types of automata, in the last, how the ways to convert the NFA into a DFA. So what is an automata? Automata is nothing but it is called a finite automata. Finite means there is a input symbols are infinite and the steps are finite. So by using this finite automata, by using this machine, we can generate finite language as well as a infinite language. It is used to recognize the patterns like keywords, identifiers, and it is used to generate the tokens. So, what is language? Because I am telling here कि we are using the recognize the pattern, generating the tokens. These all are the part of the languages. So, what is the language? Language is nothing but a medium to deliver our content, our feelings. So, in finite automata, what is the language? Generally, we talk in Hindi, English, Bengali, and other languages, but in automata, we use the language that is called a formal language, and the languages which are used in our general routine. It is called a natural languages, right? So, what is the formal languages? Formal languages are the languages that are taken and read by the finite automata. Or in summary, we can say finite automata is a simple machine that is used to recognize patterns and generate the language tokens which are used in a compiler to find the errors and the other things, right? So, how the machine works? So, in this next slide, we will discuss the tuples of automata. What are the tuples of automata? Tuples are nothing but the elements of the automata. Every automata has a 5 tuples, or you can say 5 elements. These are denoted by the Q, sigma, Q0, QF, and the delta. Capital Q is a set of the finite state. Suppose in any example, you have a 5 states. So capital Q is a set of 5 states. Suppose Q0, Q1, Q2, Q3, and a Q4. So, what is the sigma? Sigma is nothing but the finite set of the input symbol. Input symbol is nothing but it is called a alpha bits or a symbols. Suppose a machine want to read, this is denoted by, first of all, this is denoted by a sigma. In this example, suppose we are given a sigma is a comma b, means the machine will generate the string of the combination of a and a b, either a or b or both and a b. There is no any condition is given to you. So the machine can generate any kind of language, any pattern, any length of the string. It may be a, it may be AB, it may be BA, it may be ABB, like that. Suppose it is. These all strings can be generated by using this sigma. Q0 is the initial state, means where the string start to work. This is denoted by generally Q0, and the symbol is by this arrow. And fourth one is QF. QF is nothing but is the final state, that is where the machine accepts the string, and it is denoted by the circle. And last is the transition function. Transition function plays a major role in the finite automata. It tells from where you are going to the next state after reaching which input symbol. Suppose right now you are at the Q0 and reading input symbol A and going to Q1, then this is called the transition function, means you are now, right now you are at the Q0 and reading A input symbol and going to the Q1. So here we discuss what is the tuples of the automata, Q, sigma, Q0, QF, and a delta. I hope you understand this tuples, right? So what is the NFA? NFA is the first kind of the automata. Here, what we discuss, if automata, suppose automata can be represented by three ways. Either it's by a table, or it's by a graph, or it's by a transition function, right? So a finite automata is a NFA. NFA means non-deterministic automata, means there is a state of confusion. How you it's create a confusion means if there are more than one path for same input symbol. Suppose, for example, you are given a sigma is equal to a comma b, and this is a graph which is read input symbol a. This is state Q0, here B, Q1, B, and A, Q2, A, and B. In this example, this is the transition graph of an automata. Here you can see for at a state there are how many states are there? There are three states. So Q is what? Q is Q0, Q1 and a Q2. Q0 initial I represent here by using the symbol, and Q2 is the final, and this is denoted by the double circle, right? So what there are how many states are there? Q0, Q1 and a Q2. And at state Q0 you are reading input A and going to Q0, and for input symbol B at Q0 you are going Q0 as well as the Q1. So for the input symbol B you have a two choices. Either you go on the Q1 Q0, or you can go at Q1. So there is a state of confusion. Machine gets confused where it have to reach for read after reading the input symbol B. This is called a non-determinism, because for only one symbol you are getting a more than one choice. At the state Q1, same here, for input symbol A, you are going Q1 as well as Q2. This is also a state and a called a non-determinism. At state Q2, you are reading only reading only B symbol. So this is called a non-determinism. Okay. So in second point, we have discussed here or null moves. Null moves means what? You are reaching from one state to another state without reading any input symbol. This is the symbol of null move. This means what? You are not reading any symbol from this state to that state. This state is also called a non-determinism. So in this way, we can understand what is the characteristics of the NFA and what is the drawback of the NFA, which we have discussed here. So first of all, what we have discussed here, there are a more than one path for a same input symbol. Yeah, either it has no not reading an input symbol from the one state to another state. So what is a DFA? DFA is called a deterministic finite automata. This is another variant of the automata. It shows the determinism. Machine never get confused for how if there are and one path for one symbol at a time. For example, if this is the input symbol Q0, initial state, you are reading here A, I am taking here the same sigma A comma B, and you are reading B and going to Q2, reading A, going to Q1, reading A, and reading B, okay, A, B, like that. So in this case, what you see for input symbol A, At the state Q1, you are going only Q1, Q0, and for B symbol, you are going to Q2. At Q2, for reading A, you are going to Q0, and for a B, you are going to only Q2, and for A, you are going to Q1, and for A and a B, you are going to Q2. So there is a no state of confusion, and there is not any null is allowed, right? So there is, it reduces or it avoid the chance of non-determinism and kind of confusion. So if you have any NFA, that means there exists a DFA equivalent. DFA equivalent means कि if NFA is reading string AB, that means कि DFA must read the string AB. This is called the equivalent. Whenever you are going to convert NFA into a DFA, that means what? You are going to create an equivalent machine, not a new machine. You are going to create an equivalent machine which is able to read the same set of string, which is set of strings is read by the NFA, right? So here, how to convert NFA to a DFA? There is a very first step I want to discuss with you. If you are given any transition graph, in the previous examples I created two transition graph. Whenever you are going to convert NFA into a DFA, first of all convert transition graph into a transition table. Suppose for an example, I am taking here another example for the conversion. Suppose you are at a Q0. I am creating here a graph A, A, Q1, B, A, Q2, B, and B, A. Suppose I am creating this example. So what we have to do? First of all, we have to create a table. This table is called transition table, TT. This is called TG, transition graph. So here what we are the inputs. This is sigma input symbol and this represent the states. How many states are there? Right here. Q is Q0, Q1, Q2, right? So here by table Q0, Q1, Q2. There indicate is the input symbol and this is your final symbol, right? So input symbols are what is given to you. According to the graph, you have only two symbols A comma B. So here write A and here write B. This is your table started here. So what are the transition function at the state Q0? At Q0 you are reading QA and going to Q0 and forward B you are going nowhere. At Q1 for A you are going Q0 and for B Q1 and Q2 at state Q2 for A and for B at for B Q2 and Q1. Okay, let me check first. Q0 at A, you are going to Q0, right? And for B, there is no transition function is given to you. At a Q1, here Q1 for A symbol, you are going to Q0. And for B symbol, you are going here Q1 itself. At state Q2, for input symbol A, you are going never. And for the Q2 symbol, and for the B symbol, you are going B at Q1 as well as the Q2, right? So this is the transition table for NFA. And now we are going to convert into table in for a DFA. Okay. So start. Okay, only take the initial symbol inputs. Draw here Q0 and here suppose here I have to take one input symbol for a Q2, Q1. Okay, I mentioned here one new input symbol at here Q1 at Q1. So here how many states you get? Q0 and a Q1. So Q0 is already traversed. So what is the new state here? That is a Q1. So where Q1? At Q1 state, where you go to read the A input symbol here Q0, and here also for B input symbol Q1. Okay, right. Then suppose for an input symbol A, B, okay, B you are going to Q1, and for A you are going to Q2. Yes, this is right here. You are going to Q2. So this state is traversed. This is already here, and Q2 is not read by you. So here Q2 for input symbol A, no transition, and for input symbol B, you have a Q2, Q1. So you are getting here, this is the only state which we are not read yet. So here Q2, Q1. Q2 for A symbol, where are you going? 5. And at Q1, you are going to Q1. And for B symbol, where are you going? At Q2, you are going to Q2, and at Q1, you are going to union Q1. So you are getting which states? Q1 and Q1, Q2. So these all states you have already traversed, but there is a you are getting what? This is a symbol of 5. So 5 we have to introduce a new state, because at state Q2 you are not reading any symbol. So you will have to introduce a one state 5. This is your 5. Reading A is going to 5, and for reading B you are going to 5. This is the only state which we have to introduce when you get no transition for any input symbol. So this is your transition table for DFA for the given corresponding NFA. And the graph is how this is Q0, right? For A, you are going Q0. For B, you are going Q1. At Q1, for A, you are going Q2. For B, you are going Q1. At Q2, you are going new state Q2, Q1, and Q2 and Q1 are merged, and it became a final state because Q1 is merged to a Q2, and Q2 is our final state. So at Q2 for B, you are going Q2, Q1, and for the A, you are going 5, right? And here Q2, Q1 for the A, you are going to Q1, and for the B, you are stuck here, A, and 5. This is your A comma B. Then this is the DFA for the given NFA, right? So in this lecture, I discussed the concept of NFA and a DFA as well as the conversion of the NFA and NFA to DFA. I hope this lecture will help you to understand the basic concept and basic conversion of the NFA and the DFA. Thank you.